Hello, everybody. So we are going to take what we learned, a little bit about what we learned about inverse functions, and we're going to apply it to a very specific example or a specific case. And that's going to bring us to logarithms. And logarithms, it seems like a real complicated thing, but so it's important how we define this. Remember, logarithms is going to turn out, these are just numbers that are solutions to a certain exponential equation. Okay, so keep that in mind. Okay, I know we think of logs as pieces of wood we find in the forest, but here they're going to be numbers that satisfy a certain exponential equation. So here's the definition. If a is a positive number not equal to 1, then the logarithm of x with respect to base a is defined by the following. So we have this whole thing, this log sub a of x. This whole thing is one number, and it's the number y such that a to the y equals x. It's the number that you need to raise a to get x. Another way to look at this is, remember, these statements are equivalent. When we say that y is the log base a of x, this is the same thing as saying a to the y equals x. Remember, a logarithm is just a solution to an exponential equation like this. And the subscript here tells you what the base is. One thing, if you want to go a little further, remember that a log, if you don't think of a log, is an exponent. Okay, it's the exponent in this equation. So, obviously, the value of a log is going to depend on both a and x. So, just as a specific example, so a few examples here. Let's say we want to take the log base 2 of some numbers. We want to find the log of 2 base 2. Well, you want to ask yourself, okay, 2 raised to what number? 2 raised to the y is equal to 2. What's the solution to that equation? Well, obviously it's 1, right? 2 to the first equals 1, right? Or 2 to the first equals 2, right? So the answer is 1, because that's the exponent here. 2, we know that 2 squared is 4, right? So the exponent here is 2, so the log of 4 base 2 is 2. To find the log of 8 base 2, we ask 2 raised to what power is equal to 8? Well, 2 to the third, right? So the log of 8 base 2 would be 3. The log of 32, well, basically, we're saying what we really are doing is we want to recognize x as the power of 2. Okay, and we want to find the exponent. So 2 to the 5th is 32, right? So 5 is the log of 32, base 2. 2 raised to what power is 1? Well, 2 to the 0, right? Anything raised to the 0 power is 1. So the log of 1 base 2 is 0. Okay. The log of 1/2 base 2 would be -1, because 2 to the minus 1 is 1/2. And so 2 to the -2 is 1/4, right? So the log of 1/4 is -2. We know the square root of 2 is 2 to the 1/2. So this would be 1/2. The fifth root of 2, we know 2 to the 1/5 is the fifth root of 2. So this is 1/5. How is this a power of 2? Well, 1. This is the reciprocal of this, right? So we take the reciprocal of both sides. We'll have 2 to the minus 1/2 equals 1 over square root 2. So this is -1/2. And this is 1 over the cube root of 2. We know that the cube root of 2 is 2 to the third. So 1 over this is 2 to the -1/3. So this would be -1/3, right? So every statement about a log it corresponds to a state an exponential equation, right? That is, for example, the log of 2 base, let's say 16 in this case, that's 4, and that corresponds to the fact that 2 to the 4th is equal to 16, right? So remember, when you say a value is a log, we're saying that that value is the solution to an exponential equation. Okay. So let's do some more examples here. We can talk about logs in other bases as well. The log of 81 base 3. Okay, so 3 to what power? Let's say 3 to the y is equal to 81. What power was that? Well, on your calculator you can check that 81 is 3 to the 4th. Okay, so the answer is 3 to the 4th equals 81. So the actual value would be 4. 13 raised to what power is equal to 169. Okay, some of you may have memorized this, maybe not. The 13 squared is 169, so the log is 2. 1 over 25 as a power of 5, that's 5 to the minus 2. Okay, so this would be minus 2. The log of 1 base 7. Well, and we're going to see that the log of 1 in any base is always 0. Okay, because 7 to the 0 is 1. 10, the log of, to find this, 10 raised to what power is 100,000? Well, you just have to count the zeros. Okay, so we have 1, 2, 3, 4, 5 zeros, so it's 10 to the 5th, right? So this would be 5. What about log of 0.001? This turns out to be minus 3. 0.001, you can think of this as 1 over 1,000. Okay, with a fraction, it's the same thing. So this is 1 over 10 to the 3rd. Okay, so that's why which is the same thing as 10 to the minus 3. So this is going to be minus 3. The log of 1/3 base 9. Okay, ask yourself, okay, now what 9 raised to what power? Okay, 9 to the y equals 1/3. Okay, how can we solve that equation? Well, 9 is 3 squared. Okay, and we know from our properties of exponents we can multiply these out. So this is 3 to the 2y, and this is 3 to the minus 1. So 2y, so we get that 2y is equal to minus 1, so y is in fact negative 1/2. Okay. The log base 8 or the log of 0 base 8. Well, this is kind of a little tricky thing, because if you try to solve the equation 8 to the y equals 0, this has no solution, right? 8 raised to anything is always going to be a strictly positive number. Any positive number raised to a number is going to be positive, so it's never 0. So this is actually undefined. And if you put it in your calculator, you'll get an error message. Same thing happens if you enter the log of any negative number, right? 6 to the y equals negative 2. There's no solution to this, so this is undefined. Okay. So you can't take the log of 0 or a negative number. But you can take the log of 1/6. Okay, 1/6 to the y equals 1/6. The solution to that would be y equals negative 1. 4 to the 1st is 4, so this is 1. In some of these cases, it looks like it's too easy. 4 raised to the y equals 4 to the 100. Well, obviously that means y has to be 100, right? Okay, so this is 100. The log of 7, well, base 7 of this, you need to write this as using fractional exponents. The fourth root of 7 to the third is the same thing as 7 to the 3/4. Okay, remember how fractional exponents work. So this is 3/4. And the log of base 7 of this, how do we write this as a power of 7? Well, this is 1 over the fifth root of 7 is the same thing as 1 over 7 to the 1/5, and this is 7 to the negative 1/5. So the answer is negative 1/5. All right. Now, I will say we have picked relatively nice things, nice numbers. If I ask you to find the log of, let's say, 2 base 7, this exists, but we can't write this as a real nice number. It's not an integer. It's not a fraction. Okay. We know that 2 to the x equals 7. This does have a solution. Okay. Because if we can look at the graph of 2 to the x, and here's 7. So whatever this is going to be the log base 2 of 7. If this graph is y equals 2 to the x. Okay, so there is a solution, but we don't know, and this is where we need a calculator to find that. And we'll be talking more about that in the next video. Okay, but right now, get lots of practice, taking these logs, and we'll review some basic properties of logs in the next video. So I'll see you then.